Hello, I would like to talk to everybody about how we are evaluating our cutting tools, specifically our end mills. So what we're doing is a test cut to evaluate half-inch carbide end mills. We've got three different brands here. Helical, which is our standard tool that we run day in, day out, have had really good luck with. Onsrud, which we're testing for another supplier because, of course, they're trying to get our business, sell us all of our end mills. And then Iskar Tools. So today what we're going to be doing is we're going to be cutting a test part that we've came up with in carbon steel. It'll be a full slotting application. We're going to be running it on our Fadal vertical machining centers. Kurt Weiss standard work holding. There's nothing special about our machines. They're not, the super high-end pieces of equipment, but they work really good day in, day out. So operation-wise, we're going to be running our helical end mills at 3,265 RPM at 32.4 inches a minute. We'll be running the Onsrud at 3,062 RPM at 36.7 inches per minute, and the Iskar at 6,300 RPM, 50 inches a minute. All those numbers are direct from our suppliers. They are the numbers they recommend to punch them in and hit the green button. And that is basically what we're going to do. We'll get the machine all set up. We're going to run three different parts. We'll compare how they run each part, see if we can break some stuff. That's always my favorite part about testing tools. I love breaking stuff that other people gives me for free. So let's get it set up. All right, so the results are in. And what happened? There's your Iskar end mill. It didn't survive the ramp in. The Onsrud, same thing. Broke on the initial ramp in. Our helical tool end mill, it made the part, no problem. So, just in the interest of explanation, we actually did decrease the feed rate as the tool was ramping in at the 45-degree angle to 50% of the recommended speed that was given to us by the tool suppliers. And we find that that works really good with our existing helical tools, so we figure we probably want to back it off a little bit too. And we had pretty good luck with it. So the helical tool number that we're actually testing today is a 30527W. And it is a half-inch variable helix. It is our go-to tool that we use to move a lot of stock really quick. Originally what I had planned is after we had evaluated the full slotting capabilities of these tools to try pushing them in some adaptive roughing capabilities. Well, unfortunately, we broke our other two sample tools, so the only thing we got is our standard everyday tool that we run, but we're going to go ahead and run one just for fun anyhow. The parameters we're going to run it at will be about 6,250 RPM, 144 inches a minute, 1.125" depth of cut. We'll be stepping over at 0.1 inch, and then on the return cut, we'll step over 40 thousandths. It ought to allow us to rough everything out really quick and make some fun pretty chips, which is always fun. And then afterwards, we're going to hit the final surfaces that we want to clean up at 75 inches a minute, same RPM, to give it a nicer finish, to smooth out any rough edges. So I hope you enjoy. And I hope you've enjoyed seeing how we test our tools. It's not necessarily the most scientific method there is out there, but it's a way to differentiate junk tools from good tools and determine whether you want to spend a lot more time evaluating overall cutting life, total cost of ownership, all that kind of stuff. So hope you have a great day. Thank you. It's actually 0.075 step over and 40 thou on the return, not 100 thousandths. I was wrong. Thanks.